Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate. Today we are going to talk about greenhouse effect, which is basically the absorption of terrestrial radiation by selected gases in our atmosphere. I will start this video by reviewing the last video. This is the graph we spent a lot of time in our last video. Here is the wavelength in microns. Here is the radiation intensity that we receive from the sun, solar radiation, also known as shortwave radiation, and radiation that our Earth emits, known as terrestrial radiation or long-wave radiation. And here we have absorption between 0 and 100% for different gases in the atmosphere: water vapor, carbon dioxide, oxygen, and ozone, methane, nitrous oxide. And then their sum, or namely total atmosphere. We concluded that our atmosphere is pretty transparent to solar radiation, but absorbs a large chunk of terrestrial radiation, which is above 5 microns or so. We also saw there is this atmospheric window between approximately 8 and 11 microns when a lot of terrestrial radiation is allowed to escape into the outer space. But a lot of radiation is indeed absorbed by primarily water vapor and carbon dioxide. And these gases, these four gases together, are known as greenhouse gases, namely H2O, CO2, CH4, and N2O. And these greenhouse gases and greenhouse effect of our atmosphere is responsible for our planet on global average be warmer than what it would be if there was no atmosphere. In one of my previous videos, we calculated that the average temperature of our planet would be negative 18 degrees Celsius if there was no atmosphere. But because we do have atmosphere with these properties, the average annual temperature of our planet is plus 15 degrees Celsius, 33 degrees Celsius difference compared to the case without atmosphere. And that is thanks to these gases absorbing terrestrial radiation, what we also call greenhouse effect. So let us now schematically look a little bit deeper into greenhouse effect. To examine greenhouse effect, we will look into the following schematics. Here is the surface of the Earth, and here is the sun. Sun is emitting shortwave radiation, part of it reaches our planet. As we saw in previous videos, albedo of our planet is 70%, which means 30%. That means 30% of radiation is reflected back into the space and 70% is absorbed by the planet. Now, if there was no atmosphere, this absorbed radiation would be allowed to escape into outer space, like so, let's say. So, schematically, what I'm saying, this is incoming shortwave radiation that is absorbed by our planet, and then our planet radiates in long wave spectrum radiation back into the outer space. And the average temperature on our planet would be negative 18 degrees Celsius if this was the case. But we saw that this is not the case. What we do have is, of course, the surface of our planet. We do have sun over here. Sun is emitting shortwave radiation. That shortwave radiation is absorbed, 70% of it is absorbed by our planet, and then our planet re-radiates a long wave radiation. But because we do have atmosphere that has greenhouse gases, and we saw that these greenhouse gases are primarily water vapor, carbon dioxide, nitrous oxide, and methane, CH4, these gases absorb part of this radiation. When they absorb part of this radiation, let's say this molecule, it does have option to again re-radiate this radiation back into the outer space, but let's indicate here with red, it also has option to re-radiate this radiation back to the surface, thereby increasing the temperature of the surface. So we can see that if we had, let's just schematically say, 3 waves escaping the Earth's system into the outer space, in the case of no atmosphere, maybe we only have 2 waves here, and another wave, it is reflected back to the surface. So this emission of radiation towards the surface increases average temperature of the atmosphere and the Earth. Another way the greenhouse effect acts to increase temperature of the atmosphere is if this molecule, let's say this one, absorb radiation. What happens to it if we zoom in? It jiggles more. It jiggles more. As it is jiggling more, it hits this molecule over here. This one doesn't have to be good absorber. It's just any molecule, most likely oxygen or nitrogen, because they are 99% of the atmosphere. Now this molecule jiggles more. It hits this molecule, and you have more jiggling because this molecule absorbs radiation. More jiggling, we saw in my previous videos, means higher temperature of the medium. And medium here is the atmosphere. And therefore, this is why we call these gases greenhouse gases, because they absorb this radiation that would otherwise be emitted back into the outer space. Now, this is not a very good comparison to greenhouse effect in agriculture, because in agriculture, indeed, we have surface of the earth. Here are some plants that people want to grow, and they put them in a nylon plastic cover, and they call this greenhouse effect. Now, in this case, the greenhouse effect is not predominantly due to trapping this long wave radiation. Long wave radiation partially indeed is trapped by this nylon, but a lot of it actually passes. The greenhouse effect in agriculture is because this nylon cover indeed serves to protect these crops and plants from wind. So the effect of wind is reduced, but historically people call this greenhouse effect to remind ourselves to this structure over here, although the equivalence is not really the best. That's why we often call this atmospheric greenhouse effect, to differentiate between this greenhouse effect and these domes in agriculture. Lastly, which of these gases is the most important greenhouse gas in the atmosphere? By far, water vapor. Water vapor is approximately responsible for 60% of greenhouse effect on our planet. After water vapor, it's carbon dioxide, then typically methane, then nitrous oxide. There are some gases that are extremely good greenhouse gases, such as certain CFCs. You remember from my video on the composition of the atmosphere, CFCs stand for chlorofluorocarbons. Some CFCs are 20,000 times more efficient greenhouse gases than CO2, for example, but fortunately, concentration of CFCs or chlorofluorocarbons is so low in the atmosphere that currently they do not matter that much. But from the gases that matter, water vapor is the best greenhouse gas. The issue, research suggests, is that carbon dioxide and these other artificial gases, their concentrations are increasing in the atmosphere, thereby amplifying greenhouse effect. We will discuss climate change in another video. I don't want to discuss it now, but you should always remember that we should be thankful to greenhouse gas effect, because if there was no atmosphere and greenhouse gas effect, temperature of the planet would be negative 18 degrees Celsius, but that is not the case. Instead, average temperature of our planet is about 15 degrees Celsius, and that's thanks to this selective absorptivity of our atmosphere and the greenhouse effect. Until next video, goodbye.